This is section 8.4, sums of geometric series. So first we'll talk about series and summation notation, summation meaning sum. So there are two different types of series. There is a finite series, which ends, and an infinite series, which keeps going forever, and we see that by the dot, dot, dot. So we can write the sum of the series using summation notation. So for a finite series, we're going to have the starting value, the starting n or I, or whatever you want to call it, at the bottom, how many terms there are at the top, and then whatever the rule is for this series over here. If it's infinite, the only thing that changes is the top is now an infinity symbol instead of a number, right? The rule's still there, and it still starts with I equals 1. All right, so for both series, the index of summation is I, and the lower limit of summation is 1. This is called sigma notation because this is the Greek letter sigma. So we're going to write each of these series using summation or sigma notation. So for the first one, I always start by finding my rule. And it looks like I'm increasing by 25 each time. So my rule will be 25i. Right? If you use a different letter, that's fine. So 25i. So when I write my notation, we're going to start with I as 1, and I'm going to have my rule as 25i, which means my last term, if 25i equals 250, right, divide by 25, I would find that I is 10. So there are 10 terms in this sequence. And that's my answer. So for the next one, my rule, I noticed that the top is increasing by 1 and the bottom is increasing by 1. The bottom started 1 higher. So I is on top, and on the bottom is I plus 1, right? 1 over 1 plus 1, 2 over 2 plus 1, 3 over 3 plus 1, and so on. So again, we're starting with I is 1, but this time we have our top on top. So the top is going to be infinity, and my rule was I over I plus 1. So you go ahead and try these two, write each series using summation notation. Pause when you're ready to see the answer, hit play. All right, so there's our answers for these two. For number 1, the rule was 5i. There were 20 total terms. For the second one, it was 6 raised to the I power, right? 6 to the first, 6 squared, 6 to the third, 6 to the fourth. And it was an infinite series. So there are formulas that we could do to actually find the sum. So the sum of just n terms of 1, so like 1, 1, 1, 1, 1, would just be n, right? That one we're not going to really see that much. Then the sum of the first n positive integers. So if our rule is just I, then it's n times n plus 1. N is the total number of terms over 2. And if there was a number in front of the I, like 2i, 3i, 4i, we would do this and then multiply it by the number that was in front. Same thing for the sum of squares of the first n positive integer. So if the rule is I to the second power, like we just saw in that last one, that was 6 to the nope, I lied. Not like that one, but I to the second power, sorry. Then if there was a number in front, we would take the sum and multiply it by 1. And our rule for this one is n times n plus 1 times 2n plus 1 over 6. We're definitely going to have to refer back to these rules each time we have a new problem. So for our first one, find the sum. So this one is 8i. So this looks most like this one because it had just I here. So we're going to take the formula n times n plus 1 over 2. And we know that n is the top number, so 5. So it should be 5 times 5 plus 1 over 2. So 5 times 6 is 30 over 2 is 15. And this whole thing is going to get multiplied by this 8. So 15 times 8 is actually 120. And that's our answer. For the next one, we have I squared that looks like this one, and there's no number in front, so we're just going to use that formula. So it's n times n plus 1 times 2n plus 1 all over 6. So n in this case is 7, so it's going to be 7 times 7 plus 1 times 2 times 7 plus 1 all over 6. So 7 times 8 times 15 over 6. We actually get 140 as our final answer. So you go ahead and try this one. Pause. When you're ready to see the answer, hit play. All right, so this one was just K. They used a different letter this time, but it wasn't anything special, so we just used n as 6 in the n plus n, n times n plus 1 over 2, and we get a total sum of 21. So if you remember when we first started writing these, the summation notation, we could have a finite series where we had a stopping point, but we could also have an infinite one. So it's actually possible to find the sum of an infinite series as long as it is a geometric series and the common ratio is less than 1. Okay, so if it's greater than 1, the series has no sum. But if it's less than 1, well, the absolute value is less than 1, then we can find the sum. And it's going to be found by taking a sub 1 over 1 minus r. So for our first one here, my a sub 1 is 3, and my r is 0 0.7. And 0 0.7 is less than 1, so this is going to work. So we're going to take a sub 1 over 1 minus r. That's going to be 3 over 1 minus 0 0.7, which is 3 over 0.3, which turns into 10. So the sum, no matter how long I go for, will just get up to 10. That's as far as it's going to go. For the next one here, my a sub 1 is 1, and I notice I'm multiplying by 3 each time, so r is 3. Now, 3 is bigger than 1, so this is not going to work. The sum has no, the series has no sum. And that's all we could do for that one. So you go ahead and try these next two. Pause when you're ready to see the answer, hit play. All right, so first one, a sub 1 was 3, and r was 1/4. We were dividing by 4 each time. And 1/4 is less than 1, so this is going to work. I used 0.25 instead of 1/4 when I plugged it in because it just made it easier, and I got a sum of 4. For the next one, since 5/4 is greater than 1, the sum does not exist. Now we can have a little word problem. A pendulum that is released to swing freely travels 18 inches on the first swing. On each successive swing, the pendulum travels 80% of the distance of the previous swing. What is the total distance the pendulum swings? So we have a sub 1, or the first swing is 18, and our r is 0.8, because it's 80% of each one. So we can say that the sum is 18 divided by 1 minus 0.8. So that's 18 over 0.2, and that turns into 90. And since this was talking about a distance, right, it was in terms of inches, so this would be 90 inches. So you're going to try the next one, same idea. The first swing is 24 inches, and on each successive swing, it's 75% of the distance. So pause when you're ready to see the answer, hit play. All right, so a sub 1 was 24, and the r was 0.75, so we actually get a sum of 96 inches. And that is section 8.4, Algebra 2.